All right, everybody, welcome to Math with Grace. Hello, everyone. Today we are going to be going through Geometry Book 1009, Section 3 on pages 41 through 54. This section is all about lines, and it's going to start with the slope. And the slope is the slantiness of a line. New word for your vocabulary in our textbook today, the slantiness. All right, so the slope is the slant of the line. How slanty is the line? Okay, there's lots of different slopes. We define the slope of a line as the ratio of the difference in the y coordinates to the difference of the x coordinates, and that's written like this: that the slope, which is represented as an m, okay, is equal to the difference of the y coordinates over the difference of the x coordinates, okay? So here is our formula for our slope: y2 minus y1 over x2 minus x1, or sometimes it might be written as the change in y over the change in x, okay? That's what's represented by that triangle. But this is the formula that we're going to be using for a good portion of this section, if not all of it. All right, so if we look at model 1, I'll write it here, model 1, it tells us they want to find the slope of AB. Now, there's a drawing in the book, but it's unnecessary, okay? We don't need to see it right now. Point A is at -1, 4, and point B is at 5, 9. All right, they want us to find the slope of AB. It can be written like this: the slope of AB, okay? And that is going to be equal to y2 minus y1, so 9 minus 4 over 5 minus -1. Now remember, we need to keep this negative with the 1. They are partners, they are a tag team, they stay together for always. But when we do our math, we've got 5 minus -1, right? We can't have a minus minus, so two negatives like that become a positive. So then we're left with 9 minus 4 being 5 over 5 plus 1, which is 6. So our slope for these particular 2 points, the line, the slantiness of the line connecting these 2 points is 5 over 6. When we're talking about slopes, we want to remember we've got 2 kinds of slopes, okay? So here are a couple of rough coordinate planes, and we're just going to talk about the 2 different kinds of slopes, all right? We have negative slopes, okay? And they look like this. When you're walking on any of these lines from left to right, you are walking downhill, okay? Even this one here, it's not as steep, right? Its slantiness isn't very big, but we are walking downhill from a left to right, downhill, downhill, downhill. So that being said, the opposite of that would then be uphill slopes, right? Even if they're just gradual uphill slopes, we have uphill slopes. These are negative slopes, okay? And these are positive slopes. All right, so here we're walking from left to right, we're walking uphill. Our slopes are going to be positive. Here from left to right, we're walking downhill. Our slopes are negative. For this model one that we worked through, our slope was 5/6. It's a positive 5/6, therefore our line will have a positive slope going from left to right. We'll be walking up the hill, okay? So we've got to remember, negative slopes, downhill, positive slopes, uphill. Now there are 2 special slopes that we want to take a look at, and that is no slope and zero slope. And I know what you're thinking, well, that sounds like the same thing, right? No slope and zero slope, but they're not the same thing, okay? So we define no slope as any line parallel to the y-axis, okay? And there is no slope because here's a line, here's our coordinate plane, right? So here's a line. parallel to the y-axis. So what happens then is that in our y2 minus y1 over x2 minus x1, in our slope formula, our x doesn't change, right? So our x, say this was 3, then it's going to be 3 minus 3. Well, that's going to be 0. So it ends up being y2 minus y1 over 0. And we know that any fraction with a denominator of 0 is undefined. Therefore, this has no slope, okay? Undefined, no slope. The difference here with our 0 slope is 0 slope is any line parallel to the x-axis, okay? Now we're parallel to the x-axis, so that our y squared minus, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1, okay? Here, our x does change, right? It will have a value, but our y now does not change. So say this is 3 again. So it would be 3 minus 3. So here we end up having a 0 over x sub 2 minus x sub 1, which isn't undefined. It's just any number divided into 0 is 0, right? So it's a 0 slope. Okay, so no slope. Okay, these are always going to look like this. Y equals something. Okay, that's a no slope. There's no x involved. It's just y equals something. Okay, our 0 slope, on the other hand, is going to be x equals something. There's no y involved in a 0 slope. Okay, so that's a difference. No slope means no x. 0 slope means no y. All right, so let's take a look at some of the homework problems. For problem 3.1, they want us to find the slope of a line that contains these points. So we're going to use our slope formula to find the slope of this line. Our slope is going to equal y2 minus y sub 1, okay, over x sub 2 minus x sub 1. 8 minus 2 is 6, 7 minus 3 is 4. This can be reduced. Now remember, when we're talking about slopes, we do not want mixed numbers. They will always stay an improper fraction, but we will reduce them where possible. So this can be reduced to 3/2, okay? And that is our slope for this problem. For this line, this is the slope. It is a positive slope, so we know it's going to be moving upward, right? Let's take a look at 3.2. 3.2 gives us the point R at 0, 4. And the point S at 5, 0. Okay, again, they want the slope. Okay, so our slope is going to be 0 minus 4, right? 0 minus 4 over 5 minus 0. Okay, well, our top is -4 and our bottom is 5. We can't reduce that. That is our slope, and it is a negative slope. Okay. It's a negative number, negative slope. It's going to be a downhill line. All right. Let's take a look at one more from this section. And I want to look at 3.9 because I know a lot of times when we put in variables instead of numbers, it causes a lot of confusion. Okay, so number 3.9 reads out that point K is at C plus D, comma, C minus D. Okay, that's its coordinates. Point L is at C minus D, comma, C plus D. Okay, those are its coordinates. And I know it's weird, but we're going to treat this just like they were numbers. Okay, we're going to put it into our slope formula. So we've got y sub 2. Okay, I'll label them this time. Feel free to label them when you do your work always if you need to. I'm just going to label them this time because I know it's a little bit more confusing, right? So y sub 2 is C plus D, okay, minus y sub 1, which is C minus D, okay, all over x sub 2, which is C minus D, minus x sub 1, which is C plus D. Now, remember, when we have a setup like this, we've got to distribute our negative sign throughout, okay? So now this becomes C plus D minus C plus D, right? All over C minus D minus C minus D. Okay? Got negative C here, negative D. We got that. Negative C here, positive D. All right, so now just in the numerator and the denominators on their own, we're going to cancel what we can cancel, okay? We have a positive C and a negative C, so they're gone. Down here, we've got a positive C and a negative C, so they're gone as well. Now we're just going to add these up, okay? So we've got 2 D's at the top, and we've got negative 2 D's at the bottom. Well, this is 2D over 2D tells us that this is the same equivalent as 1, right? Our negative sign doesn't disappear though, so it stays. We just carry it over. This is the same as negative 1. Our slope for this wacky set of points is just negative 1. Negative slope, downhill slope. Okay? Good job. Let's take a look at a couple other problems here. Number 311 tells us that point P is at 3, 2, and point Q is at 8, we don't know. Okay, but they do give us the slope as being 3/5. Okay, so now they want us to figure out backwards what point is our y sub 2, right? So just like normal, we're going to put this into our formula. Remember, our slope is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1, okay? So our slope, which is 3/5, is equal to y sub 2, which we don't know, minus, and I do realize I made a mistake there, apologize, minus y sub 1, which we do know is 2, over x sub 2, which is 8, minus 3, which is x sub 1, okay? So now we just work this out like a normal math problem, normal algebra, right? 3/5 is equal to y sub 2 minus 2 over 5, okay? If we multiply both sides by 5, all right, these 5s both cancel, so now we have 3 is equal to y sub 2 minus 2. We can add our 2 to both sides and learn that our y sub 2 is at 0.5. All right, so we just went backwards on that problem and worked it through, okay? There's a couple other problems like that in your homework. And then a note that the book wants to make before it starts up with the next set of problems is that you need to remember that the slope is going to be the same for any points on a line. So any collinear points on the line will always give you the same slope. With that being said, let's look at problem 316. Okay, 316 asks us, test the following points to see if they are collinear. If they are collinear, then all of the slopes between between 2 points will always be the same. Okay, so it gives us point R at -1, 1, point S at 2, 4, and point T at 6, 8. So we want to test all of the connections here. So first we will find the slope of, let's say, RS, okay? So the slope of RS will tell us that 4 minus 1 over 2 minus -1, okay? Remember, minus minus equals plus. So 4 minus 1 is 3, 2 plus 1 is 3. So the slope between those 2 points is 1. Next, let's find the slope of our ST, okay? The slope of ST is going to be 8 minus 4 over 6 minus 2. All right, well, 8 minus 4 is 4. Make sure I'm on screen here. And 6 minus 2 is 4. Well, 4 over 4 is 1. So its slope is 1. So far, so good, right? Now let's find the slope of TR. Okay, now I wrote it TR, which means R is my sub 2's. Okay, so it's going to go first here. So we've got 1 minus 8 over -1 minus 6. All right, that tells me 1 minus 8 is a -7. -1 minus 6 is also a -7. Negative divided by a negative gives us a positive. So that tells us that its slope is also 1. All right, so we've checked every point connection possible, right? They've all come back with a slope of +1. Therefore, each of these points is collinear. Yes, they are collinear points, okay? Between all of them, they all have the same slope. Therefore, they all must be on the same line, okay? So that's what that section wants you to do. Test the slopes between all the different points given to determine whether they are collinear or not. The last problem specific to slopes that I want to talk about is problem 324. And it asks us to find the slopes of the sides of a triangle whose vertices are at these points. So 0.13, 0.35, and 0.62. So they want us to find the slopes. Now they've already listed all the slopes that you need to find. So the first slope here is PQ. Again, our formula for the slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1, okay? So PQ, that tells us that we want 5 minus 3 over 3 minus 1. 5 minus 3 is 2. 3 minus 1 is 2. Therefore, our slope here is 1. Okay? The next one they list here is they want you to find the slope of QR. All right, well, that tells us that we need to put 2 minus 5 over 6 minus 3. Okay? 2 minus 5 is -3. 6 minus 3 is 3. Therefore, this slope is a -1. All right, then we've got the slope of RP, okay? Remember, follow the list, the order that they give you. That tells us that we've got 3 minus 2 over 1 minus 6, okay? 3 minus 2 is 1. 1 minus 6 is a -5, okay? Therefore, we know that that's our slope for those, between those 2 points, is at -1/5, sorry. Okay, so now we have the slopes for each of these sides of our triangle. These are the different slopes of our triangle. Problem 25, which I'm not going to work through here on this video, but I think you guys can handle it, tells us then to find the slopes of the medians of the triangle in this problem, problem 24. Now, you've already got the slopes of the sides of the triangle, but they want you to find the slopes of the medians. So you need to find the midpoints like we did in the last video, okay? In the last section, you're going to have to find the midpoint between each of these, okay? And then use that point with the opposite vertice, okay, to find the slope of the median, all right? Take it one step at a time. Find the midpoint. Then use that midpoint, and it's going to be a weird one. You know it is. You've done these midpoint ones enough to know that they aren't going to be nice and neat numbers, okay? You're going to use that midpoint and the opposite vertice point to find the slope between those, okay? What is the slantiness of the median, all right? Not too bad. You guys can handle it. One thing I want to talk about real quick before we move on, because it's actually even the next section, are parallel and perpendicular. I want you to take note of the fact that this triangle has one line with a slope of 1 and another line with a slope of -1, okay? And these are opposite inverse slopes, right? 1 is the inverse of 1. The inverse and opposite of 1 is -1/1, which is still just -1, right? These are opposite and inverse slopes. Therefore, they are technically perpendicular. So this happens to be a right triangle because it has a perpendicular vertice. Okay, it has 2 sloping sides that are perpendicular to each other. But we're going to talk about that more in just a second. Okay, so now we're talking about it, all right? Parallel and perpendicular lines, all right? So theorem 9.4 tells us that two non-vertical lines, so they're not going straight up and down, right, are parallel if and only if they have equal slopes, okay? So two lines parallel if their slopes are equal, right? You know how I like to abbreviate things, okay? So, la-di-da, coordinate plane. Okay, we've got two lines. Are they parallel? Aren't they parallel? Okay, there's lots of different ways we could figure out with our mad math skills whether or not these lines are parallel. But if we take 2 points from each line and figure out the slope of each line, okay, and say the slope of this line is, I don't even know, 1/2, and the slope of this line is 1/2, then we can say that yes, these lines are parallel because their slopes are equal, okay? Their slantiness is exactly the same. Therefore, they will never cross each other, right? Which is the definition of being parallel, okay? Now, theorem 9.5 tells us that two non-vertical lines are perpendicular if and only if one of the slope of one is the negative reciprocal of the slope of the other. Okay, so two lines perpendicular if and only if the slopes look like this. Okay. The slopes have to be, I guess, not equal, but one slope is a slope and the other slope has to be the negative reciprocal. Okay? Although they show it as equal in your theorem too. So I'm going to put my equal sign back. All right. So looking at that, kind of like the problem that we just did, okay, we've got our coordinate plane. Okay, and we've got a line here and a line here. Okay, the slope, like we talked about in our last problem, the slope of this line was -1, right? The slope of this line was 1. Okay, 1 and -1 fill this criteria, right? 1 is equal to the negative of -1, right? They end up being equal. It's a negative reciprocal. So therefore, these lines, I don't know why I erased it, are perpendicular to each other, okay? They form a 90-degree angle. And in the case of that problem we just talked about, it was actually a right triangle that they were forming, right? Because we were working with a triangle, okay? Now, when you look on pages 46 and 47, there's a huge, vast explanation of why this is the case. You know how they love to work through theorems? Feel free to read that on your own. Now, if we take a look at problem 326, it tells us that the lines K, L, M, and N have the following slopes. So line K has a slope equal to 2/3. Line L has a slope equal to -4. Line M is -3/2. And line N is its slope is equal to 1/4. So they want to know which pairs of lines are perpendicular. So remember, when we're talking about perpendicular, we need opposite reciprocals, okay? So let's take a look at line K. Is K perpendicular to anything? Its slope is 2/3. We need an opposite reciprocal. Well, 4 doesn't fit the bill, right? But if we look at line M is definitely the reciprocal and the opposite. So line K is perpendicular with line M. Okay, let's look at line L. Its slope is -4. We've already determined it's not perpendicular to M or K. So let's look at N. Well, the reciprocal of -4 is 1/4, right? And because we need the opposite, here we have a negative and here we have a positive. So line L and line N are perpendicular to each other. Okay? For the rest of this section, they're going to ask you these kinds of questions. You're going to need to find the slopes in most of them and determine whether or not these lines are perpendicular or parallel. I'd like to take a look at one more problem in this, talking about parallel and perpendicular lines before we move on to equations, and that's problem number 37. Now, 37 gives us the points of A, B, and C at the respective locations, and they want to know, do these following coordinates form right triangles, yes or no? To find that out, we need to find the slope of each of these sides of the triangle, right? So we're going to start with the slope of AB. The slope of AB gives us a 1 minus 1 over 7 minus 2, okay? Well, we know that 1 minus 1 is going to give us a 0, while 7 minus 2 gives us a 5. Now remember, from when we talked about it before, any number divided into 0 is 0. Okay, this is 0 slope. Okay, what is that? How is that represented on our coordinate plane? Remember, a 0 slope is represented as a horizontal line. Okay, let's look at our next slope. Okay, we're going to look for the slope of BC. Right? Well, we know that we're going to have 4 minus 1 over 2 minus 7. 4 minus 1 is 3. 2 minus 7 is a negative 5. So our slope here is, here's our 0 slope, is negative 3/5. Okay? And then we have the measurement for, or not the measurement, sorry, the slope for CA. Okay? Well, the slope for CA is going to give us 1 minus 4 over 2 minus 2. Okay, 1 minus 4 is a negative 3, but 2 minus 2 gives us a 0. So now we know that this is undefined, and therefore we know that this has no slope. Okay, it's not a 0 slope, remember, it has no slope. It's undefined. It has no slope, which is represented on our coordinate plane as a vertical line. All right, so is this or is this not a right triangle? Do we have two sides that are the negative reciprocal of each other? Well, in this case we do, right? Because we have a 0 slope, or a completely horizontal line, and a no slope, which is a completely vertical line. And we know that when you cross a completely horizontal line with a vertical line, that you are going to get perpendicular lines. And you have got to have perpendicular line, at least, well, only one set of perpendicular lines, you can only have one, to form a right triangle. So yes, this forms a right triangle. Okay, good job, guys. All right, our next topic is equation of a line. Okay, here's an equation of a line. And one way for us to find the points on that line are to, what we're used to doing anyway, is solving for y and then plugging in points. So first let's solve for y, right? So we're going to subtract our x from both sides. And we're left with 3y equals 2. And I'm going to just move the x into the front. Negative 2x plus 12. We're going to divide the whole thing by 3. So that y is going to be equal to negative 2/3 x plus 4. Okay? Now we've solved for y completely. So one way to figure out which points of a line that we have here is to use a little chart then, right? We have our x and our y. We should all have had experience with this in the past. And we choose a point for our x, and then we solve for y. What would that work out to be with our y? And I always like to start with 0 because it always seems to be the easiest, right? Because any number times 0 is 0. So all that's left over is the constant that's there. So if x is 0, then y equals 4. Okay, that is one point on our coordinate plane. 0, 4. That this line passes through. All right, so now let's take a look at, and let's say, what if our x were 3? Well, if x was 3, our 3's would cancel and we'd be left with a -2 plus 4, or a +2, right? So the next point on our coordinate plane would be at 3, 2, or one of the points, not the next one, obviously, but just an easy one to solve for. Okay, well, if 3 works, then I'm going to try -3. And I know these aren't in order, but that's really not the point. We're just trying to solve for convenient points, okay? So we knew that if we put a -3 in here, that our 3's cancel, right? And so now we have -1 times a -2, which gives us a +2. So now we have +2 plus 4. So that's at 0.6. So one of our points then would be at -3, 6. Okay, and you can go on, choosing, put a 6 here and cancel out, you know. I like to choose just simple things. Obviously, you can choose 1 or 2 or whatever else, but then we're dealing with fractions, and I ain't got time for that. So I like to choose the simplest ones that will make it work out nice. But that gives us our coordinate points. And from those coordinate points, we've got at least 3. We can actually find the slope of this line by solving with our slope formula, right? Well, that leads us into theorem 9.6, or 9-6. It says, the graph of any equation can be written in this form, this original form right here, right? AX plus BY equals C, where A and B are not both 0, right? They can't both be 0 at the same time. It's a line, okay? If you've got a formula, an equation that can be written in this form where A and B are not 0, then this does indeed form a line, okay? So all of that equals a line. That's the basic theorem here. So we walk right in then to also theorem 9.7 that tells us the equation of the line passing through point x sub 1, y sub 1, x sub 2, y sub 2 is given the formula. Okay, ready? Y minus y sub 1 is equal to the slope times x minus x sub 1, okay? Where your slope, you use your regular slope formula, okay? And obviously my x sub 2 cannot equal my x sub 1 because that's going to give us a undefined problem, okay? And this is called the point slope equation or form, okay? Here, this y and this x do not actually represent a point on your line. They represent this y and this x, okay? Basically, this is what I drew right here. This is my point slope form, okay? We changed it from standard form to our point slope form so that we could solve for our points here, right? But knowing now that theorem 9.7 tells us that this is how it's set up, that our slope is times x minus x sub 1, we know then by looking at this equation that this number right here is our slope, okay? So the slope of this line is -2/3, all right? We learned that through this theorem, okay? Our slope for this line is -2/3 because this is where it falls in our point slope form. Okay, so let's look at model 1. And this all might be swirling around, but let's just take a look at model 1. Model 1 reads, find the equation of a line passing through points, point A, which is at 3, 4, and point B, which is at -2, -1, and express the equation in the form of, right here, AX plus BY equals C, where everything is an integer. This is the standard form. Okay, standard form. They want it expressed in standard form, but they want us to use this theorem up here. Well, for us to use this theorem, first thing we want to do is solve for our slope. Okay, so our slope is going to be equal to negative 1 minus 4 over negative 2 minus 3, right? Negative 1 minus 4 is negative 5. Negative 2 minus 3 is negative 5. And therefore, our slope is a positive 1, right? Negative divided by negative gives us a positive. It's the same number. Our slope is a positive 1. Now we can use our formula, our point slope equation formula here, and put in our numbers. Y minus y sub 1. Now here, you can just choose. Honestly, it can be either both the points from A or both the points from B. It doesn't matter. You can choose either one you want. Just make sure you use both of the points from there. The example in the book uses point A, okay? So I'm just going to go ahead and walk you through point A because I don't want it to be confusing. But if you use point B for this equation, it will still work out to be the same, believe it or not. But let's use point A because that's what the book chose to do. So it's going to be y minus 4 is equal to my slope of 1 times x minus 3. Okay, so y minus 4 is going to be equal to, basically this 1 doesn't exist, x minus 3, right? Now remember, they asked for this in the standard form, which means our x and our y need to be on the same side of the line. Or sorry, same side of the equal sign. So I'm going to subtract my x on both sides. So now I have negative x plus y minus 4 equals negative 3. Let's add our 4 to both sides. So now we have negative x plus y equals 1. Okay? Now, this is a proper answer. You can be happy and content, and that can be your answer. A lot of times in the book, though, they do not want your x to be negative. And sometimes if you're looking at the answer sheet to check your work, they will show it written with the x being a positive number, because that's how a lot of times it's recorded. So to do that, basically you would just multiply the whole thing by a negative 1, right? So that would give us a positive x, a negative y, and a negative 1. These are formulas. These two things are the exact same line. Okay? That is the exact same answer. It's just that sometimes the book wants the x to be positive. They don't want it to start with a negative number. Okay? So know that, understand that these two things are exactly the same. Okay, let's take a look at some of the homework. If we take a look at problem 342, it asks us to write in the standard form of the equation of the line passing through this given point. Okay, so here are our points. And remember, our standard form, okay, is ax plus by equals c, right? But usually to get there, we need to use y minus y sub 1 equals the slope times x minus x sub 1. Okay, we're going to have to use both of these parts to get to here. This is the answer they want. We're going to need this formula to get there. But first thing we need to find out is our slope. Okay, and our slope is going to be 2 minus 1 over 5 minus 4. 2 minus 1 is 1, 5 minus 4 is 1. Our slope is 1. Yay! Okay, now we can plug it into our slope formula equation, and tells us that y, let's see, which one did I use here? I used A. Okay, so y minus 1 is going to be equal to, I'm not even going to write my 1 because we all know that 1 times anything is that thing. So let's just do this portion of it. Okay, so it's going to be x minus 4. Okay, now we can solve this. We can move our x over here, and I'm going to move my 1 at the same time. We're good multitaskers that way, right? So we have got negative x plus y is equal to negative 3. Now again, that might not be the answer in the answer key if you're checking your homework. So know that the same exact line could also be written as x minus y equals 3. Okay, all we did was flip the signs on each of the terms, and we get the exact same answer. Both of those answers are correct. Let's look at 343. Okay, 343 gives us point R at 3, 3, and S at -6, -6. Again, first things first, we need to know our slope. So our slope is going to be -6 minus 3, okay, over -6 minus 3, which is -9 over -9, which again is a slope of 1. They're going very easy on you at this beginning, okay? So now let's put it into our slope form, and let's use point R. It doesn't matter. Like I said, you can use S, you can use R, it doesn't matter. Just remember now when you're using a negative number, and we've got y minus, if you use a 6, it would be y minus -6, okay? Just remember that. So we've got y minus 3 is equal to our slope of 1, which I'm not going to write. So it's got x minus 3, okay? Technically, we have a -3 on this side and a -3 on this side. They're going to cancel each other out, so I'm not even going to bother moving things around. But then we can, I'm just going to move the y this time. Okay, so we have 0 is equal to y minus, or, oh goodness gracious, x minus y, or basically x minus y equals 0. Same thing, okay? So that is the formula, or the equation, I'm sorry, of this line that passes through these 2 points. X minus y equals 0. All right, let's take a look at one a little bit more challenging at 349. 349 gives us the point S at 1/2 and 1, 1/2, 1, and T at 1/2, 4. All right, just like before, first things first, we want to find our slope, okay? Our slope is going to be 4 minus 1 over 1/2 minus 1/2. Okay, well, right away we can notice that there's a problem, right? 4 minus 1 is 3. 1/2 minus 1/2 is 0. What does that tell us about this line? Okay, 3 divided by 0 is an undefined term. It's an undefined equation. Therefore, we know that this has no slope. Okay, how is no slope represented? Horizontal or vertical? Okay, a no slope line is a vertical line. Okay, if we had a coordinate plane, it is a vertical line. Therefore, it's going to be x is equal to something. Okay, well, what is our x equal to here? Okay, x is equal to 1/2. That is the standard form of your equation for this line, right? Here's a half, here's a half. X is equal to 1/2. You could put in the numbers here and actually work it out, but there's no need. We know that this is no slope. We know that it has to be x equal to something, and that x is equal to 1/2. The next problem we're going to look at is problem 352. In it, the directions read, write the standard form of the equation of a line passing through the given point and having the given slope, okay? So now we don't even have to figure out the slope to put in our work into our formula because they've already given it to us. So we can write that y minus 5 is equal to 3 times x minus 5, right? We're going to make sure we distribute our 3 all the way through. Y minus 5 is equal to 3x minus 15, okay? Just like before, we're going to move our x to the other side, okay? And we're going to move our 5 across the equal sign as well. We're doing that in one step because we're gangster like that, okay? So that gives us negative 3x plus y is equal to negative 10, okay? Well, that's a nice looking thing, remember, in the back of the book. So I just want you to get comfortable with changing this over. They almost always want a positive x. So this line is correct, but it's also correct written as 3x minus y equals 10. Okay? 3x minus y equals 10. Both of those are correct. Let's look at another one like that. Let's look at 353. So they've given us point B at 6, 2 with a slope, the line passing through that point, it has a slope of negative 1/2. So what is the standard form? Okay, Well, we've got y minus 2 is going to be equal to negative 1/2 times x minus 6, okay? The easiest way, we've done this in the past, to get rid of this negative 1/2 is to multiply the whole thing by 2, right? So we're going to multiply both sides of this equation by 2. So that leaves us with 2y minus 4 equal to, now these cancel, right? So now we have this negative that we're going to distribute through. It's equal to negative x plus 6. All right? Let's add our x to both sides. And let's add our 4 to both sides so we can move those both at the same time. Okay? We're left with x plus 2y is equal to 10. Okay? So that is the standard form of the equation, or the line here that passes through this point and has a slope of negative 1/2. Remember, when we've got those fractions out front here, just to make it easy, let's just multiply by its reciprocal and get it out of there, okay? And here is what we end up with its standard form. Let's take a look now at problem 358. I didn't have this one marked to go over with you guys, but I want to talk about it, okay? They want to know the equation of the given line in standard form that passes through point negative 3, 4, and is perpendicular to a line whose slope is equal to 2/5. Okay, what does that mean? That it's perpendicular to a line whose slope is 2/5. Remember, perpendicular means opposite reciprocal. So that tells us that the slope of our line is equal to what? We know it's going to be negative, right? Because this is a positive number. We want then the opposite, which is negative, and we want the reciprocal. So the slope of our line passing through point negative 3, 4 is negative 5/2. Okay, that's our slope. Now we can use that information and plug it in like we have been. Y minus 4 is equal to negative 5/2 times x minus a negative 3. Okay, remember, minus minus gives us what? Minus minus gives us plus, okay? And now we have 5/2 to deal with. Well, just like we did in the last problem, we're going to multiply both sides of the equation by 2. We walk out of here with 2y minus 8 is equal to, our 2's on this side, cancel each other out. So now we have negative 5x, remember we have to distribute this all the way through, minus 15. Okay? Negative 5x minus 15. Our 3 got changed to a positive 3, but then we subtracted it by a negative 5, and it ended up negative again, okay? So now we're going to add our 5x to both sides of our equation, and we're going to add our 8 to both sides of our equation, okay? Cancel, cancel. We're left with 5x plus 2y is equal to, okay, negative 7. Okay, so here is the standard form of a line that passes through point negative 3, 4 and is perpendicular to another line that has a slope of 2/5. Okay, perpendicular tells us that our slope was a negative 5/2, the opposite reciprocal. All right, last problem we're going to go over today in this section for this video is problem 362. So for this problem, they want to know the line containing the hypotenuse of the right triangle ABC, where these are the vertices, point A, point B, point C, okay? They want to know the line containing the hypotenuse. Well, first thing we need to figure out is which line contains a hypotenuse. So let's look at our slope, okay? Our slope of AB is going to give us 1 minus 5 over 1 minus minus 5, okay? Minus minus gives us a plus. So we've got 1 minus 5 being a negative 4 and 1 plus 5 being a positive 6, which we can then reduce to a negative 2/3. So our slope of the line between AB is negative 2/3. Let's look at our slope of the line BC. Our slope of our line BC is going to be 4 minus 1 over 3 minus 1. Okay? 4 minus 1 is 3. 3 minus 1 is 2. So it's a positive 3/2. Now, before we even find the slope of the next line, let's take a look at this. what do we have here between these two things? We have negative reciprocals, right? Therefore, we know that AB is perpendicular to BC. So if AB, and I'm just going to free draw it here, if AB is perpendicular to BC, which line is our hypotenuse? Right. The line opposite of our perpendicular, or our 90-degree angle, so line AC is our hypotenuse, okay? So let's find our slope for AC then, because that's what we need, right? Our slope for AC is going to be 4 minus 5 over 3 minus 5, okay? Minus minus gives us a plus. 4 minus 5 is -1. 3 plus 5 is 8. So our slope for AC is -1/8. All right, now we have our slope. We have our point. You can either choose point A or point C to put into our formula. I chose A, it looks like. So y minus 5, okay, is going to be equal to -1/8 times x minus -5, okay? Minus minus gives us a plus, okay? Now, just like we took care of our half over here, now we have 8. It's a bigger number, but whatever. We're going to multiply both sides by 8, okay? So we're going to walk out with 8y minus 40 is going to be equal to, those cancel, but don't forget this negative still has to be put through. It's going to be equal to a -x minus 5, okay? Let's add our x to both sides and add our 40 to both sides, okay? Cancel, cancel. We are ending up with x plus 8y is equal to 35, okay? Here is the standard equation of a line containing the hypotenuse of this right triangle, okay? We had to figure out, first of all, where our perpendicular lines were that formed our right triangle. That led us to the fact that our extra line was our hypotenuse. We found the slope of our hypotenuse and then used it in our point slope formula to figure out the standard formula of the line passing through here containing those 2 points. Okay, we've gone through a lot of slopes and lines and all kinds of slantiness here, and it's been great. You guys have done a great job. Okay, continue doing your work, get your self-test done, and then guess what? That's it for this book. We are not doing section 4 of this book. So, that being known, if you take a look at your unit test, which almost none of you do anyway, but if you decide to do it for some miraculous reason this time, you do not have to do number 25. And I will be emailing out your actual alt tests to you, and I will have crossed out the problems within which you do not have to do. We are not doing section 4, so this is our last section of this book. Great job. We're moving on to our last one. Good work, everybody. Until next week.